So also in terms of RabbitMQ, so that was just about what RabbitMQ is. But now in terms of the architecture of RabbitMQ, we have these three components that are in RabbitMQ. So the first one is these producers. These are these producers the messages and they publish the messages into the exchanges. And so the good practice is I see a number of producers producing it directly to the queue, but a good implementation of it is to publish into the exchange, and then as you publish them into exchange against publishing them into the queues, and then they are being used or consumed by the consumers from the queue. So exchange is also a very nice item within it. This is very responsible in terms of routing or creating the routing logic in terms of where do we route this message based on what and stuff like that, making those decisions. And we have here a number of routing or exchange types that gives us now this very good logic. Like the first one here, direct message, it means you're just routing to an exact key. Let's say I'm publishing one message here which needs to go to this node service, or maybe I'm publishing from an HR system, I'm publishing one packet that just need to be consumed by this Python service or this particular service that does this particular function. So you can just do a direct message into that service. Number two is the topic. So this topic, it's like a wildcard for flexible routing. For example, you can just have a wildcard of all the messages that has this particular format in the exchange will be consumed by this particular client. So you can have a lot of clients consuming messages or picking from the topic depending with now the routing key, or given the routing key having something like wildcard flexibility to be consumed by a number of services. Then the third one is fan out. So this one now is used basically for broadcasting. You want to create one message here and then broadcast to all the other all these services that are listening in. So all those subscribed services will receive that message at a go. Also, you have headers which you can use some metadata. This is basically metadata that you can use within the headers of the packet to just define how you are routing these messages, how you are routing to the different services. That's a very good feature within Rabbit. Then we have now the default exchange, which is explicitly or explicit queue routing, which you can just use it as by default. So the second one is that exchange, and then the final one is the queue. So these three are the major components within RabbitMQ. So within queue, we have some bonus features in RabbitMQ. That's why I'll vote for it 10 times. We have features like the message TTLs. I don't know if here down. So we have these features like message time to leave, and you have stuffs like DXL. This is the dead letter exchange. So this time to leave is, you can say this queue can just leave for this number of milliseconds or seconds or minutes or hours and stuff like that, and then you can check them out at this particular point. That's a very good feature. And then this dead letter exchange, that one is basically to handle failed deliveries gracefully. The first one is to just auto expire messages. So this one is just auto expire messages. Say you want this person to stay in the queue, or this particular packet, I want it to stay for a day in the queue, and then execute or maybe ship it out. So that should be able to do that. And then for the DLX, it can be used to now manage just those failures, or it handle those failed deliveries gracefully. If the queue was not well delivered, it will automatically kill it gracefully. And then there's also confirm select. This third one is basically for producer level message confirmation. So it confirms from the producer if the message was successfully delivered or if it went successfully. Then there's the consumer acknowledgement and non-acknowledgement, or not acknowledged, the NACs and ACKs. So these are fine-grained control over the failures for the particular messages. And then out of that, we have the HMA RAD queues. This is basically, it guarantees availability for high availability. And then we have quorum queues. Quorum queues are rough-based consensus for high reliability, just giving you like an agreement or a consensus within your producer and the consumers on the same. Then we have the shovel federation. This is a cross-DC messaging movement within your queues. And then we have the stream queues, which is like Kafka-like, which has a very high throughput streams in terms of if you want to do maybe a video streaming platform like Netflix, then you can choose these type of functionality within your queue. It will give you a very good throughput in terms of delivery.